Factoring continuous. Factoring a trinomial, you open two set of brackets. You throw an x in each one. Then you look for two numbers that multiply to give you 30 and add to give you negative 11. So since they multiply to positive and add to a negative number, then both of them have to be negative. So it looks like negative 6 times negative 5 will give you positive 30, and when you add them, they give you negative 11. The second one, factoring a trinomial again, x, what multiplies to give me negative 6 and add to give me negative 1. There's a 1 there, so that's negative 1, so that's negative 3 plus 2. You multiply them, they give you negative 6. You add them, they give you negative 1. Here, if I look deep enough, I have the greatest common factor, which is 3. And I get x squared plus 5x plus 4. One more step. I rewrite the 3, open two set of brackets to factor this trinomial right here. I put an x in each, two numbers that multiply to give me positive 4 and add to give me positive 5. That's not 2 and 2, but 4 and 1. 4 times 1 gives you 4. 4 plus 1 gives you 5. Again, I look here and greatest common factor, so I'm factoring out a negative 4. Remember, when you factor out a negative, it's a sign changer. So this will be x squared. That negative will become plus 7x. And the plus here becomes minus 30. Close the bracket. One more step. Negative 4 x multiply to give me negative 30 and add to give me 7. That's plus 10 minus 3 because they multiply to give me negative 30, and when I add them I get positive 7. We go to this. I think this one I forgot to write. There's a y attached to the 36. That's a y squared. So when I'm doing this, when I open my two set of brackets, I put an x here, an x there, but because of this y squared, I have to put a y at the end of each bracket. And therefore, now what multiplies to give me positive 36 and add to give me negative 12? That's minus 6, because negative 6 times negative 6 give me positive 36. When you add them, they give me negative 12. You could always FOIL this to see that it give you this. So if you want to go ahead and check, you could just FOIL it out and then it will give you this. That's what factoring is, the opposite of FOILing. Here, again, greatest common factor, I could see it all over. So the x is the greatest common factor. The y's, there's a y in each one of them, so y. And when you take out the greatest common factor, that's from the variables, you just look at the variable with the lowest exponent. That's what you're going to take out, And another way of doing greatest common factor, if you want to know what you write in the brackets, you go this divided by this, it gives you x squared, minus this divided by this, it gives you 11x, and then this divided by this, it just gives you negative 60. Now one more step, xy, open two set of brackets, x in each, multiply to give me negative 60 and add to give me negative 11. It's minus 15 plus 4, because negative 15 times 4 is negative 60. When you add them, they give you negative 11. Now this one, see this x plus 1 squared, and there's x plus 1. This follows this kind of rule, except you have to simplify this question, let m be x plus 1. And then you could replace these expressions by m. So you could write m squared minus 2m minus 15, which factors into x minus 5, x plus 3, negative 5 times here give you negative 15. When you add them, they give you negative 2. Now it equals, you have to put back the x plus 1 for every m. And sorry, that's should have been m right there, because what I'm factoring is m squared minus m. So I should have wrote m here. m there, but m, we let m equal x plus 1, so now we go back and sub x plus 1 in each m in the factored form. So x plus 1 minus 5, and then the other m plus 1, and then the plus 3. So therefore, final answer, m minus 4, m plus 4. That's done. See you next time. Thanks for watching.